I love the taste of fresh fruit or vegetables grown from my own garden. I've grown strawberries and tomatoes and kale and lettuce, all sorts of things. But I've never really grown anything that grows in clusters, like grapes, which is too bad because I bet I'd have a great analogy right now. But I will say this. With all gardening, there are those who know how to put something in the ground, and then there are master gardeners who know how to take care of it. And I want us to be master gardeners of NSX. And that's why right now I want to look at some advanced NSX controller management with you so you can feel confident knowing how to manage those controller nodes in your environment. So putting on our elite hat and doing some advanced management of our controllers, we're going to be on VMware's HOL 1903 lab, and we'll fire up Google Chrome. Log on as the administrator at vsphere.local. Put in the default lab password of VMware1 ! With a capital VM. And we'll go full screen. Now that we're logged on, we're going to go ahead and head to layout settings. I'd like to be able to see recent tasks, so I'm going to add the check mark for that. That'll be useful later on. We'll go ahead and unpin it so it's not taking up so much real estate. And then we're going to head over to networking and security, NSX Central. We're thinking about controller management. Where should we go from here? Well, on the dashboard, of course, we've got the green light for our controller nodes, so that's good. Let's go to installation and upgrade. Now our temptation is going to be to jump right over here to the NSX controller nodes. But before we go there, there's actually a core controller option that's right here in front of it. I want you to take a moment and look at this NSX manager that's in front of us and see what you see that relates to controllers. We've got two elements here that relate to controllers. The first one is the version up to date, because the controller could be at 6.2, whereas the manager could be at 6.4, and although it'll work, it's missing out on features that it could use. So that's the first thing it's telling us there. The second thing is the CDO mode. That's a controller question right here, is whether or not the CDO feature has been turned on. So CDO stands for Controller Disconnected Operation. This extra resiliency feature that helps to ensure that we can connect to VMs even when all of our controllers are down is disabled by default, even with a fresh installation of 6.3 or 6.4. So it's up to us to say, I want that extra resiliency. I want VMs to work even after a vMotion when I've had a loss of all controller connectivity. So to enable it, we'll simply select the NSX manager, then we'll head up to Actions, little drop down right above it, and enable CDO mode. Ask if we really mean it, we say yes, and we can see we've had a successful enable of that state. Awesome. One small step to make yourself extra resilient. Let's make sure that this is selected once again, and on the actions menu, let's take a look at what's available now. Let's talk about these bottom three actions because they all relate to controllers. The first one is to update the controller state. Updating the controller state would be necessary if we actually went in and changed our VXLAN or logical router configuration, the kind of things that we do over on these other tabs, and we needed to immediately cause the controllers to receive those new settings. Update controller state is the tool that uses the manager to tell the controllers what new controller settings now apply. Of course, if we don't want that CDO mode that we just turned on, we have disable CDO mode, pretty straightforward. And then down at the bottom, we have resync CDO mode. Hopefully you won't have to use this. This is kind of a emergency fix operation, because if there ends up being any corruption inside the universal VTEP table that the CDO mode creates, then you can try disable it and it says, I can't do it. So in that case, we need to resync the CDO mode to essentially clear the table and then disable it. It's a specialized way to essentially re-perform that last step of usually attempting to disable CDO mode. None of those options are needed right now, so we'll go ahead and click away from that. And let's head up to NSX controller nodes. Now under NSX controller nodes, we can see our current configuration of our specific controllers. Remember, each controller is really a VM that is going to be held on some ESXi host somewhere. And in this configuration, we notice a distinct lack of 2 more controllers, right? 3 is a magic number. That's how many controller nodes you want to see in production. To avoid overpopulating the shared lab environment, VMware has only deployed a single controller. When we think about deploying those 3 VMs, would we want those to all be hanging off of one poor ESXi host? Of course not. That would be horrible, right? We want to make sure that these are on separate ESXi hosts for their deployment so that there is some load balancing. In our management cluster, however many hosts appear on that, it would be great to protect those VMs with both high availability and DRS depending on resource utilization. Let's select controller 1 And I'd like for you to notice there's this great option here, support logs. Let's click that. It tells us it's collecting tech support logs for one controller. If we click to view details, we can see, yep, it's chugging away. All right, we can close that. So the tech logs have been generated now. We can click view details, and there's the link to actually download that as an action. Yeah. Let's go to the drop-down menu, choose show in folder, and there we go. This is a big long name there. It's a TGZ file, so this local system doesn't have the ability to extract that. You need something like 7-zip or WinZip, something like that can actually work with Unix archive directories. But inside of here, we would find the support information associated with this specific controller, the operations it's performed, how it's functioned, that sort of thing. Would there be any way to get this kind of information live without having to go through this big grab all the log information and looking at it that way? I bet there is. Let's do an F11 to pop out of this full screen mode. And down at the bottom, let's open up PuTTY. And in PuTTY, we can connect directly to 192.168.110.31. Let's go ahead and load that. And we'll put in the password of VMware1 exclamation point, VMware1 exclamation point. There we go. And now we're on the NSX controller looking at the CLI. Haha, the CLI, raw power. There's probably something like a show logs command, right? Show logs? Hey, look at that. And it gives me a list of various different logs that we can delve into. So we've got lots of logs here with exciting date timestamps. We can press Q to quit. You get the idea. So various different logs with all sorts of different aspects to look at. We have deep technical logs, and we also have the higher level error information and warning logs, as well as the security logs associated with authentication. So to see the details of a specific log, let's type in show log cloudnet/cloudnet.info, and then press enter. I'm using info because it's a very broad log with lots of information already inside of it. It shows things like sockets opening, connections being made, waiting for state change, right? We can see the processes that are going on in the mind of the controller. Let's type in a Q, and I'm going to up arrow to bring up that last command, and I'm going to add the switch filtered-by hello in all uppercase. So now out of that big, huge file, we filtered down to just those lines that include the text string that we threw in there. So I just wanted you to see, it's not that hard to dive into the logs and be able to see what's going on. Just PuTTY into your controller and find the log information that you need. In addition to log files, let me just mention one other quick command that's very useful from a controller perspective when puttying into one of our controllers. We can type in show control-cluster logical-switches. There's actually a lot of great commands off this root. And then reference a specific VNI. So let's say VNI 5000. This is a way to track down the controller that is associated with the VNI. So we can see it's 110.31, not any of the others that are hosting VNI 5000. Let's exit. We're done with PuTTY for now. And with controller 1 selected, let's select actions in the vSphere web client. Not a ton of options here, but we can update the controller cluster password. So if that password gets out of sync, we can, in fact, come in and update that with a new password. So we could put in, VMware2 exclamation point if that's what we want. A couple times, remember, minimum 12 characters with complexity. Type it in and confirm it. It is a good idea for security purposes, of course, to not leave the same password in there. That password helps to prevent any kind of compromise to the integrity of the system, right? If you leave the same password, someone happens to know that password, software could be created that could impersonate a valid controller instance and cause all sorts of mayhem on your network. For now, we'll just cancel. Let's go to the Actions menu again and take a look at Fetch Disk Alerts. So why look at these disk latency alerts? If we have controllers running on disks that have a high latency, and high really meaning anything where the peak latency is above 300 or the average latency stays above 100, then we have concerns, all right? We've got a system that's going to start having issues, errors, disconnecting, not responding well. And of course, the fix for that is to go to our storage manager and make sure that the storage environment that is hosting the VMs of our controller infrastructure are able to respond more quickly. Now, the information that we're seeing in front of us is not an alert. It is the potential for an alert that is not being realized. You'll notice there's no exclamation points over here on the left-hand side. That's a sure flag. What we're seeing is actually great. Our latency is, in fact, less than 300 for the peak, less than 100 for the average. The way the alarm system works, there's what's known as a high watermark of 200 milliseconds and a low watermark of 100 milliseconds. And so as the average latency increases, when it hits 200 milliseconds or greater, then a full-on alert will be triggered. And that triggered alert will stay in place until such a time as we dip below 100 milliseconds. So just so you know where those alerts are coming from and why, if you've gotten down to 110 milliseconds, it's still giving you grief. Let's close that up. And before we close, I want to show you one final operation. And I say final because what we're going to do is going to break our lab environment, but I still want to show it to you anyway. In certain circumstances, I've experienced controllers that would not respond. There were some password synchronization errors, and they simply would no longer function. In that state, I was not able to log in. I couldn't recover them. I didn't have a backup copy of all three of the controllers to be able to restore, anything like that. So what could I do? In that scenario, I deleted. Let's try it. Select controller 01 and choose delete. And it says, are you sure? Because, I mean, this is your controller, and for unicast operations, that's how you get the VTEP information shared. And you're going to say, yes, I'm going to do this because my controllers aren't working anyway, right? This is a last-ditch scenario. Proceed to force delete and click delete. And it says, okay, boss, I guess we'll delete it. If you click under recent tasks in the bottom left, if you brought it up like I did, you can see it powers it off, and then it deletes it. 1-2 punch, and now it's gone. If we go back to our installation and upgrade and refresh our page, we can see we no longer have a controller node. So now that everything's gone, what do? Don't worry, we can rebuild. Just click the Add button on the left-hand side, and we'll put in our VMware 1 exclamation point, VMware 1 exclamation point, confirm that, and then click Next. Then the name for this, we'll just call this C1. Go down to Cluster or Resource Pool, we'll put that in the Management Cluster. Data Store, we'll choose the iSCSI. Host, we'll choose ESXi4. I'm just tabbing and down arrowing. You can also click and use the drop-down menu. For the network, we'll open that up and select ESXi region, the distributed switch for management. Click OK. And then the IP pool, we're going to use the controller IP pool that's already been built with addresses that will be able to connect to the manager. Then we click OK, and then click Finish. Now, I thoroughly expect this to fail. Real world, I would not expect this to fail. It builds it back right away. In this case, it's going to fail, and that's okay, because that just gives us another learning opportunity. In the bottom left-hand corner, let's click Recent Tasks. And you can see, there's my issue. In our lab environment, there is insufficient disk space to deploy a new controller. So that's okay. We're going to end the lab at this point. But I want you to go through the process, see how easy it is to delete and to rebuild it, and to be aware that if you don't have enough disk space, it's true, you can't create new VMs. I'm hoping that's not a new concept for you. My friend, by going through this hands-on lab together, you've learned some of the tools and tasks that are associated with controller management, because those controllers are what control the control plane when we're working with unicast communication between our hosts and NSX. I hope this has been informative for you, and I'd like to thank you for viewing.